is now in listen-only mode.
Good morning, everyone. This is Dr. Meng Mangu from the Horticulture Department at Texas A&M Agri-Life Extension Service. And today we have Dr. Derald Harp, Ph.D. Professor of Horticulture at TAMU Commerce, Rodrigo Diaz, and Dr. Yan Chen from LSU Ag Center. They will be our second presenters. Miss Laura Miller are my favorite hort agent in Tarrant County, and also Erfang is going to do our last presentation on this series of four CMBS webinars. And Erfang, you're ready, right?
Sure, yeah, I can go right now.
Okay. Well, unfortunately, today is our Derald. Like I said, Derald is our star today. So Derald, you're ready?
I'm ready.
All right, let's go.
Okay, look forward, and thank y'all for having me. There we go. And I want to thank y'all and provide greetings from the campus of Texas A&M University-Commerce. For those of y'all that don't know where we're at, we're about 60 miles northeast of Dallas, about halfway between Greenville and Sulphur Springs. We've been lucky enough, and we're very happy to be able to talk to you about some of the control methods that we've been looking at, and primarily using mechanical controls, trying to find ways to control them using non-chemical means. So if you're part of this presentation, you're part of this webinar, then you're probably already familiar with the bark scale. We know that this is a felt scale, which means that it doesn't form the hard coating that we see in the armored scales that we see there. In our area, we're going to be looking at somewhere probably between 2 to 3 generations per year. This is going to vary according to the year, but as soon as it starts to warm up, it looks like the critical temperatures is going to be in the mid to high 60s. We're going to start seeing that first generation start. The eggs hatching, the crawlers start to move, and we see temperatures in the high 60s. For us, that's going to be late March, early April. Sometimes we have a cool spring, it'll push that back a little bit. Early season, those generations don't progress very quickly. Somewhere between 100 and 120 days for that first generation. But as we start seeing temperatures up into the upper 80s, now we start seeing them kick a little bit faster. And we know upper 80s for us is going to happen pretty quickly in May, and sometimes even quicker than that. By the time we get into the summer and we're seeing temperatures, our typical 95 to 100, those generations can move pretty quickly, which is why we can see 2 to 3 generations per year here. And there have been reports of a 4th generation in Dallas. If you're in South Texas, San Antonio, Houston area, you're probably going to see 3 to 4 generations per year. This is going to be important when we start looking at some of these control measures. Generally, these insects are going to overwinter as adult females or egg sacs. There are some reports that they will also overwinter as nymphs hidden underneath loose bark or in crevices on the tree. Right now, we know some of our best suppression is using neonicotinoids, whether it's imidacloprid or dinotefuran. These provide good suppression throughout the year. But we have people and we have clients. My background is not only here, but I also spent about 15 years in the landscape industry, Dallas-Fort Worth area, primarily doing high-end residential installations and some large-scale maintenance. You're going to have clients out there that want an organic method, or they want at least a pesticide-free method. And so this is a method that can provide some control, some help there. So we started with our trials. This is the Plant Science Center at A&M Commerce. We have 24 trees, 4 cultivars, and there's 4 plants each, so 24 total. 4 of these were the Black Diamond cultivars. We did have 5, but we had some problems with Black Diamond Pure White, so those were replaced with Tonto. We also have one that came out of the Oklahoma State program. This is Centennial Spirit. These are our Crapemyrtles. These range in height anywhere from, since the Tontos were the latest planted, they're probably only about 4 feet tall. The Centennial Spirits are probably in the 8-foot tall range now. So we did 6 treatments here, and this is Michaela Bledsoe, my graduate student, working on one of these treatments. No treatment. This is our negative control. This is the one that we want to get infested so that we know we have that infestation maintained. We had some issues with that, but I'll explain that later. We had a safari drench, which is the Dinotephuron. We're using this as the positive control. Then our mechanical methods were a soap and water scrub and a power wash. And on each of these, we also added a Suffol X, a horticultural oil treatment to these as well. Our mechanical treatments were applied in mid-February. We just set the date. It was the second Thursday in February. That was the day that we picked, and that was just what we were going to stick with. We had a soap solution. Basically, we have 1 tablespoon of Dawn dish soap and 3 gallons of water in a bucket. Take a brush. Ours had fairly stiff bristles, but it didn't. They weren't so stiff that they damaged the bark. But you sit there and you hand scrub every branch, every stem from the top to bottom until everything is completely clean. We also used a power washer, and this is what you can see P.D. Castillo spraying here. Use a power washer. This is a gas-powered power washer. This one generates about 3,100 PSI max. We used a 25-degree spray nozzle. One thing I looked at on this, we had access to an 1,800 PSI electric model. I don't think it actually did as well a job. You had to get closer to the branch. With this one, we were able to stay about 12 to 18 inches from the branch. If you get closer, then you can damage the bark, you can damage the wood. If you get further away than that, we found you really weren't doing much cleaning. In both treatments, we either hand scrubbed or we sprayed the trees until you just could not see the sooty mold anymore, okay? The horticultural oil treatments, we use Suffol X. We sprayed this starting the next month after our spray treatments. Did this the first week of March, first week of April, and the first week of May. That first week of May for us corresponded when we had a pretty healthy bud break. And so that was our last treatment. If anybody's familiar with Suffol X, one of the things that we need to be familiar with that is it should not be applied on any plants with foliage or any foliage once you see temperatures above 95. And for us, again, that happens pretty quickly in the summer, and we've already seen some temperatures that hot this year already. We sprayed the entire trunk, again, went from the top of the tree all the way down to the bottom. This is jumping ahead in the results a little bit, but suffice to say, we didn't see, similar to what we've seen in previous studies, the horticultural oil didn't seem to provide that much control or didn't seem to make that much of a difference. Now, again, we think back to the lifespan and how quickly those generations are moving. That first generation, if the temperatures are cold, it may not have started moving until by the time and missed most of the sprays already. So it's hard to say what's actually going on there. And so here I want to talk about some of the results, and I separated these for one reason. We've got the crepe. I want to talk about the Crapemyrtle bark scale itself, and I want to talk about the sooty mold. The Crapemyrtle bark scale, as we looked at this, if you look, you can see that this is September of 2018. We used a scale on ours to measure this. What we did is we used a 0 to 10 scale. A plant with a 0 we saw no evidence, we found no bark scale, we found no eggs, we found nothing on that tree. Okay, a plant with a 10 would receive would be essentially completely covered in bark scale. You would have a hard time finding some part of the plant where you wouldn't see it. This is what we think of as those severe infestations, where anybody can go up to the tree. You see the small white bumps on the tree, or small white insects on the tree, even if you don't recognize what they are. Then you see them and you know you've got a problem. Okay, that's a 10 for us. As we started the study in the year prior, September 18, our average was a 4.17. Of this, of the 24 trees, all the trees had bark scale at some level. I believe our lowest rating was a 2, the highest was a 7 or an 8. But every plant was infested, and So we had complete infestation throughout that. We came back in late winter of 2019, and we applied our treatment. And we can see that by the time we get to June, that now we're at an average of 0.032. This is under 1, and this is across all treatments. So we did at least get some initial suppression. As we go up, move into July, now we're still under 1, and so we still got good suppression throughout the year, but we do see those numbers ticking up. Now, this is numbers across all treatments, and so this includes everything. So I want to spend a little bit of time looking at the treatments individually. If we look at this dark blue line right here, this is the dinotefuran. And you can see how it got very good suppression and kept it very, very low. So we saw virtually no bark scale on those trees. We do see an uptick here. This is one of our power wash, and this is let's see if I can move my screen a little bit. Oops. We've got an uptick here. Now we're back up over 3 on these. So some of these we're starting to see some pretty good bark scale infestations on. So number one, what we're seeing is the mechanical methods are not going to provide the same control that a chemical will. As we look across the treatments, we start seeing these numbers. We're at 1.5 here and over 3s in both the scrub with oil and the power wash. One thing that's interesting that I do want to point out here is our control method is actually quite a bit lower than what we expected. One explanation and our thoughts on this is by the time we got into early spring and things started moving, we had wiped out most of the bark scale that were on these trees. Okay. We did have, and we have seen pretty significant predator populations, especially numerous different types of lady beetles out there. We didn't count them, we didn't quantify them, but we did see them quite a bit. And so our thought is now the controls are likely the only trees that have a significant bark scale population, allowing the predators to concentrate specifically on that population. Now, importantly for us, and as I mentioned before, my background is in landscape industry in Dallas-Fort Worth. So I'm concerned about, and I'm used to dealing with clients who are wanting their projects to look as good as possible, especially landscape maintenance. Sooty mold, for me, at least when I talk to people, this is what a lot of people see. This is the easiest factor related to bark scale for people to see. The black branches, the dark gray that runs down the stem and becomes very visible. With this, we start off at about a 3.5, again, using that same 0 to 10 scale. But notice that as we begin the year across all treatments, we're under 1. But notice that it stayed that way all the way through the end of the year. Now, we didn't take data in October or November. We did notice that when we got in November, we started seeing some leaf drop. We did notice that the sooty mold had returned then. But throughout most of the growing season, we didn't see the sooty mold come back. Across the treatments, we see very similar. Now, again, we see dinotefuran, the safari providing the best control, and basically we didn't see sooty mold come back on those at all. And we are seeing an uptick starting in about July, but notice that it's still under 1 here. It's only in August that we start to see about a 1.5, and we're still below 2. So we do get some pretty good suppression of the sooty mold. And notice here, even though we see the big bars, we've got no sooty mold in the dinotefuran. And even our strongest treatment is the power wash. We're still at a 1.5. So we're still getting pretty good suppression of the sooty mold. Again, from a visibility standpoint, this is really what we're interested in, and we think is part of the good news from this study. And As we expected, mechanical methods are not going to provide, or they don't provide, season-long control comparable to dinotefuran. Once we've done that initial treatment, we can control that. We can limit and reduce that first generation, but any subsequent generations, we don't have any further control. The good news for us is that the sooty mold was very slow to redevelop. And if we can control the sooty mold, then we can limit the appearance in our landscapes. The things we do know, the control is not going to be complete. As hard as we work trying to get every nick and cranny, there's always going to be something in that tree that you miss. One thing that's going to be an issue is if you've got particularly tall trees. All the trees that we have, our tallest tree was 8 feet tall. If you've got a 25-foot natchez, now that's a different story. It's going to take quite a bit more work to get through that tree. We also have the issue of high pressure. If you're getting too close to that tree, then you can cause damage. So that's something that's going to have to be a consideration. But we do have some benefits. We can get limited suppression. We can reduce the numbers, especially early in the growing season. So anything that we reduce at the beginning is going to allow us to have further reductions later in the season. The nice thing about this, and from a landscape management perspective, one of the things that I've thought about in February as a landscape maintenance manager, I'm looking for things to keep my crews busy. I'm looking for things to keep my guys active. And this is something, it's a service that could be that your clients could be very interested in, and something that will benefit your employees, because now you've got a work service. Now, we do have some issues because we are going to have lifts. We are going to have some better controls of the overall system of how it's going to be washed. But those are some challenges that I think creative people can handle. We do get suppression, and so we aren't using any chemicals with this. So this does benefit for pesticide-free landscapes and organic landscapes. I do want to thank the people that helped me do this. I want to thank Dr. Gu and the rest of this team for providing all the great information and the opportunity to work with everybody. But I do have to thank my crews that have worked for me. There's the graduate students I've worked with for the last 2 years, and they're working on this project. This is Michaela Bledsoe, Kanan Sutton, Tino Mendieta, Taryn Bashaw, and Andrew Savage here, along with several other student workers that we didn't get pictured. But again, thank you for the opportunity to share this information, and be happy to look forward to answering any questions that you have later. At this time, it's my turn to turn this over to Dr. Rodrigo Diaz to talk about biopesticides.
Hey, thank you, Derald. Thank you very much for the information. I want to tell you guys, during our transition in the chat, please find the registration to the next two, webinars. The next two webinars, it's in the chat. So I have the links there. At a certain point, you guys could click on those links and register for the next two webinars. So Rodrigo, you ready?
Yes, can you see my screen?
Yes, beautiful. Go ahead.
Fantastic. Good morning, everyone. My name is Rodrigo Diaz. I'm going to speak with you about our work with biopesticides. And this work was conducted with my graduate student, Giovanna Matos, and my collaborator, Dr. Yan Chen. And here we're in beautiful Baton Rouge. So let's talk about biopesticides. So let me see, I need to change this. Okay, so next. So in terms of biological control, I'm glad that Derald already introduced this topic, and we keep hearing about this role of these coccinelles, these beautiful lady beetles, helping controlling some of these infestations, at least locally. So it's very important for us to keep in mind the role of these natural enemies. But we also understand that basically because of this localized distribution, they may not have a greater control in some of the greater regions. And that brings, to the topic about, the management, how as a team we're addressing these different tactics to manage Crapemyrtle bark scale. We understand a little bit about how the coccinelles predate on the scale. Derald mentioned the role of washing on the scale, and there is some information that we are learning about this, right? And we also were learning about insecticides. So I like seeing these as this multi-pronged approach that we're trying to put together to address this scale. And at the same time, something interesting is that you all are aware that several homeowners are asking for other alternatives, including more organically or more environmentally friendly, if you want to call. And this is when the biopesticides are available. And we do know this because, several of these products are available in the market. What are biopesticides? So think about these as, products of virus, bacteria, nematodes, of fungi. And they do have some active ingredient that may affect the development and eventually the mortality of these insects. So here I wanted to share this picture that Giovanna found, and in the picture you see a cricket with two fungal structures coming out of its body, right? So this is, some example of what we call an entomopathogen. Yeah, you see the poor cricket already, the cadaver and the fungi emerging. And what we also know is that we would search in the literature, there is some bacterial and fungal biopesticides that they have shown efficacy against the scales. So there was some precedent about all of this, right? And in the way that these products enter through the insect is eventually through these natural openings that they have in their bodies. Now, with that background, we wanted to evaluate the efficacy of commercially available biopesticides. I'm going to name each of them later. But at the same time, as we see this role of these natural enemies, we see the coccinelles in the trees. We wanted to see how, as we spray these products, what's going to be the interaction that they have with these natural enemies. So these will be the two topics that I'm going to cover today. In terms of the efficacy, we selected 5 products. We have 2 bacteria, that is a Chromobacterium and also Venerate on the first 2 on the left. And then we have these fungal products, including Iseria, Beauveria bassiana, and there were 2 different strains of Beauveria that we evaluated. Again, these products is where you find available, at least in the US market. And then we contact the companies to address specifically what would be the best recommendations for these, the rates for application of these products. So what we did is, here's a picture of Giovanna counting a scale. So we did a greenhouse trial where we put all these products to the test, including water as control, right? So we have our little plants infested with the scales, and then we spray these products with a CO2 pressurized backpack sprayer. Now, something important that we want to address, and this is the one fascinating and at the same time challenging aspect of working with the bark scale, is that you need to address whether they are dying, whether we're having an impact on mortality. And if you work with an insect that walks and then it disappears, eventually you see them moving away from the plant. But in the case of the scale, if you are killing the scale, the cadaver will remain on the plant. And we need to make sure that we address that, how you account for mortality, right? So we counted the scales, and then we compare these among treatments, right? So these are the results. When we did this greenhouse trial, you can see here the different products on the left first column, and then the percent of Crapemyrtle bark scale development. This is basically active scales that molted. And as you see, there was no difference among the treatments that we sprayed, with 83% of the scales actually successfully molted, versus, all these products have, similar rates that statistically were not different. So that triggered a lot of questions saying, well, what happened? And we started thinking about the greenhouse conditions, etc. But something important that helped us with our thought process is that when we address the bacterial products, there was a precedent about that maybe these products may not be as effective against this scale. So for the subsequent trials, we decided to work with these fungal products, specifically Iseria, Beauveria, and Beauveria bassiana, those 2 strains. So you will see our further field evaluations will be under these 2 conditions, right? And this is basically what is explaining about the issue with bacterial products, right? Now, in terms of when we went out in the field, this will be the campus here in Baton Rouge. We have the scale covering our several trees on campus, including one right next to the tiger on here on the main campus. So it's really easy access to us. So we have this beautiful set of trees that were infested, and we did these trials in different seasons. As you hear from the presentation before, it's very important, the seasonality in the system, right? What happens in the winter, the spring and summer and so on. So these results, we put these products to the test in the winter. As you see, the temperature close to 17 degrees centigrade. Okay, so let's see. In the way that we did it, we have we spray the biopesticides, and here will be Giovanna collecting branches out of those trees, and we collected and assessed the mortality every 2 days for a 14-day treatment effect, right? So, and something important about these products is that, well, you're spraying these living organisms. You name it, fungi, viruses, nematodes. Something very important that in these early stages of the process is, well, are we able to recover? Are we infecting those scales with this disease, right? With these pathogens. So what we did is collected some scales from those trees. We brought it to the lab, and then we put it in this media that let the pathogen, if it is present, grow, right? So this is what you see in the pictures, the scale with infection, and then we put it on the plate, and then eventually monitor the plate to see, hey, can we get the pathogen to grow again, and see if actually the scales in the field got the pathogen. So we also did a fall experiment, also with a temperature of 16 degrees centigrade. In this case was some potted plants, because as you can imagine, the plants that we used before in the campus, the trees, we didn't have scales for some reason, right? So we decided to do this. It's still in the field, more realistic, but actually with potted plants, right? So, and then of course, as we did was, every certain period of time, collect some samples, bring them back to the lab, and actually assess scale mortality, right? So what I'm going to show you now is the pathogen confirmation and the scale mortality trials. What you see in this picture are actually scanning electron microscopy pictures where the surface of the scale, where you can see some pathogens in those red arrows, compared with the surface of the scale in the control, that they are actually, they just were sprayed with water, and they are not, we didn't see any fungi type of a structure. So that was quite important to confirm. But in addition, remember those Petri dishes where we recover these products? It was pretty awesome to say that, yes, the scale got the infection. And that was just fantastic as a proof of concept. The product that you're delivering actually is what you're recovering from those individuals. And then you see the pictures of the Beauveria bassiana in this area infecting those scales. So that was pretty awesome. That was very exciting. I remember seeing Giovanna that, yes, we see the recovery of those pathogens from those scales. So yes, they are infecting the scales. So in terms of mortality, as you can see here, is this will be the percent recovery of the pathogen, meaning that as we collect scales from specific trees with a specific product that were sprayed, most of the time you recover the same infection, because it may happen that some of these spores of these pathogens will move, but in fact, most of these products, as you can see here, you recover the pathogen that you sprayed in the specific tree from the scales. So that was pretty nice to say, that you recover the same product, but maybe some overlapping right there. In terms of impact, here you have the treatments in the first column. You see in the winter trial how we have a 46% scale mortality in the Beauveria bassiana A&T treatment compared with the water that was a 26% mortality. So yes, we got this percent mortality in the winter. We didn't see difference in the spring trial, but in the fall trial, that was actually the, Yes. So in the fall trial is when we saw this difference. In this case, with the GHA strain with 63% mortality versus 27 of the control. So it varies. The efficacy of these treatments vary per season. Now, that got us thinking, what may be explaining these seasons, and I'm glad that, again, the previous presentation targets these issues that we're having, right? So in the winter, you know that the scales are going to be along the bark, and perhaps we have a better product coverage in the winter, right? And then the same in the small potted plants, that we were able to just cover those plants with the product more effectively. And then in the spring, when we have those monster infestations throughout the branches, is perhaps with maybe that dispersal and the product application may not be as effective. So again, in the practical perspective, think where the scale infestation is, depending on the time of the year, and how your management action needs to be changed based on the location of your population, right? So again, this just highlights the issue about this greater exposure of biopesticides probably led to a greater mortality, right? And this has been confirmed in other systems where they have used biopesticides. Now, in terms of this is, I just want to emphasize this issue, like, as ERFAN has been published, in fact, about the seasonality of the scale, when they are present, and what part of the scale the tree are infested. That's something that seems to be really important as a key issues to manage these populations, right? So something else that Giovanna did is that, we're spraying a living organism. So they may like specific temperatures, right? Like any of us, we may be more active at, 60 degrees Fahrenheit compared with that 95. Same story with this organism, right? What you see in these graphs is that the temperature range where she got greater spore germination, right? As you see, these different fungus on the left, and then you see these greater peaks, right, between these 23 to up to 30 degrees centigrade. So that gives you a sense of, when is the ideal temperature conditions for them to germinate, right? So that was something very interesting. And, when the temperatures get really hot and then you put these products, they may not do as well. At the same time, when it's too cold, 8 to 12 degrees centigrade, maybe germination may be limited. And that just brings more ideas to developing these management plans. It's saying, well, how my tactic is being affected by temperature. In this case, is when the spores may be more active, right? So in terms of summary of the Crapemyrtle bark scale mortality, we definitely know that Beauveria bassiana strains definitely have some efficacy against the bark scale. There is other strains available that could be evaluated as a method of control. Remember the issue about temperatures. When you spray these products, they may be limited in terms of, what would be the ideal conditions. And then I cannot emphasize this because I remember seeing Giovanna and going through this and saying, we definitely need to be careful with in terms of product coverage. We try to do it, but as you can imagine, and you hear before, the size of this Crapemyrtle varies drastically, right? Now I have a short section, as I mentioned before, about the role of this interaction. As we spray these products, as we use insecticides, or as we use these oils, etc., they interact with natural enemies. So in this case, what I wanted to show with you guys is our initial attempt to address these interactions, right? So what we did is to address, let's go to some sites in Louisiana and let's find out what are the most common natural enemies here in this part of the States. So we did a survey in Shreveport, Baton Rouge, and Houma. We went to some infestations, collected branches from trees, bring it to the lab, and then we count everything, right? What is in these branches. Something very interesting is that right there, the lady beetles, they become the more frequent natural enemy that you guys see. You have Chilocorus, Harmonia, that is the Asian, that this is a non-native lady beetle, and then Hyperaspis bigeminata, which is native. So, and then sometimes you see green lacewings, and sometimes you see minute burette bugs, but by far, these native coccinelles are the most important natural enemies, at least in these locations. So in the practical perspective, probably all of you should be able to recognize how they look, these lady beetles, when they are active, etc., because locally they may be playing a critical role, especially, you know, we notice a lot of activity in this case in the springtime. So these are our system, right? So we identify what are the natural enemies, so now we're going to expose them to these biopesticides. Okay, so what Giovanna did is just literally dip these coccinelles that you see on this tube in the products that you see in those right here, and then address later, you know, you see, you put it in these petri dishes and to see if actually they get infected by these pathogens. So in terms of survival of these trials, what you see here is that, yes, these lady beetles, the survival of them may be affected by these products. As you see here, you have this product, Beauveria bassiana, the GHA strain. These reduce the survival of these lady beetles. As you can see here, you know, they die sooner compared with the water control that you can see here in this line. So yes, they reduce the survival of these individuals, at least in this laboratory with this heavy exposure, right? We also have the lady beetle larvae, you know, that they are also voracious predators. So she also found a lower survival, as you can see in the second graph. They just die sooner compared with the water control when they are being sprayed with this Beauveria bassiana GHA strain. And then with this other lady beetle, this would be Hyperaspis bigeminata. Also, the GHA reduced the survival of the adults. You see how they die sooner. Kind of similar story with the bigeminata larvae. So, and what this means is basically we say, well, definitely these products may reduce the survival of these individuals. So what Giovanna decided to do is to go in the field to those trees where she sprayed already and address whether the pathogen actually infect the tree, they infect these coccinelles in the field. So that's what she did. So she went out in those trees and then started looking for these coccinelles, and then she brought them back in the lab. Remember, those trees had the different application of these biopesticides, right? And then in the laboratory she observes fungal growth. What you have here is that when she was able to extract the DNA of the pathogen to confirm the strain, because the morphology, you cannot separate between strains, but using DNA, you can because of the level of specificity of this method, okay? So using that method, Giovanna say, yes, when you spray GHA strain, you get the coccinelle from that tree, and yes, that coccinelle is infected by that product. And this is what this graph is showing. Basically, this is the percent infection of these coccinelles when you spray with these products. So what this is very interesting just means that, you know, they are being in contact with these products, but what we haven't seen is, you know, what will be the long-term impact of these products on the survival of these lady beetles. So as a conclusion of this part, you know, these coccinelles, Chilocorus, cacti, and Hyperaspis geminata, and Chilocorus stigma, they are quite common in our service. This product, the Beauveria bassiana GHA, reduced the survival of all the larvae and the adults of these coccinelles. And then, of course, yeah, these NA3 reduce the survival specifically of these Chilocorus adults. So that's very interesting, these levels of specificity on their impact, right? And Neisseria reduce the survival of larvae. Now, if we put this in perspective, you know, we definitely need to understand, okay, we can get the reduction in survival, but when we are in the field, seems to be that we definitely need to increase our understanding about whether, in fact, maybe these coccinelles may be dispersing the spores of these pathogens, perhaps even therefore basically being, you know, carriers of this disease to other scale infestations. So this is, something that we have been very interesting as a follow-up, saying, okay, you get the infection of the coccinelles, but can that maybe facilitate the dispersal of the pathogen to other locations? Because as you know, the coccinelles move, especially the adults, of course, fly and move a lot. So in terms of recommendations, we can say that, biopesticides containing Beauveria bassiana have a potential to manage the scale. As you saw in those graphs before, natural enemies were abundant in the spring. We need to be watching for them and see, how our tactics perhaps may change to facilitate the role, especially if they are abundant. Of course, that's what I mean in terms of spraying, avoiding spraying natural enemies, especially the timing of your application, the timing of your control tactic. And then spraying biopesticides with the scale seems to be that, we are definitely can have a greater control if the spraying directly has a better access to the scale. When you have these super large trees, perhaps, and with the infestation throughout, maybe that may be, we need to, again, find a way to improve our coverage, especially under those large applications. And with that, I would like to thank you for your attention. Thanks for this opportunity to talk about biocontrol. My idea was to present you, how we are, as we study these interactions, as we study these applications, these products, how they may be integrated in this overall IPM approach that we're trying to develop. But again, I want to thank for the funding agencies. I want to thank you, Meng, for organizing this presentation. And I will be happy to take any questions if this is the right time. Thank you.